to check. So if I run my program, as you can see, we get this very, very big number. Okay, one very important thing that you must have each time that you work with recursion is the following. So every time that you work with recursion, you must have this base case here, which will stop the recursion from happening again and again and again. So this base case here will stop invoking recursive sum function at a certain point when a certain condition is reached. And unless you have that base case which will stop the recursion, you will have that function invoking itself infinitely, so infinite number of times, and you will get an error. So in order to demonstrate that, I will remove this base case here. So let's comment it out. And if I run my program now, as you can see, we get a Stack Overflow error, which means that, as I already said, this recursive sum function is invoking itself again and again and again, infinite number of times, and this recursion never stops. And in order to stop it, you need to have a base case which will stop the recursion. So I'm going to close the program now, and I will return this code here, which is our base case. And if I run my program again, as you can see, we get the expected result and the error has disappeared. So that is something very important to remember. Each time that you use recursion, you must have a base case to break that recursion from happening infinite number of times. So I hope that you understood what is recursion and how it works. And in order to practice on your own, I will leave a task for you. And the task is following. So I want you to do the factorial of a number using recursion. Calculate factorial of a number using recursion. And if you are not familiar with what factorial is or how it is calculated, I will leave a video link here where I'm calculating factorial of a number using loops. And then what I want you to do is to do that same task using recursive functions. And you can paste your code in the comments down below. So I hope that this video helped you understand what is recursion and how it works. And if it did, give it a thumbs up and subscribe to my channel. And also, you can follow me on my other social media if you want. The links are in the description. Thank you very much for watching. I'm going to see you in my next video. Bye! Hi everyone, welcome to my channel. My name is Saldina and I make IT and programming related videos. So if that is something that is of interest to you, consider subscribing to my channel and give this video a thumbs up as well. Now, in this particular video, I want to talk about object-oriented programming. So what is object-oriented programming? Well, OOP, or object-oriented programming, allows you to represent real-life objects in programming. And those real-life objects are going to be represented together with their attributes and then their behaviors as well. One of the most important concepts of OOP are classes and objects. So let me explain the difference. What is a class and then what is an object? A class is going to represent a template, meaning a blueprint, and then an object really represents an example of that class, an instance of that class. For example, a class can be a fruit, and then an object of that fruit class can be an apple, a banana, a peach, or another example, a class can be a car, and then an object of that class can be a Volvo, a Ford, a BMW, and so on. And that car class, for example, has some attributes and then it has some behaviors as well. Now, what are attributes of car class? Well, a car has a name, for example. That's an example of one attribute. And then it has a price and max speed and color and so on. And then behaviors of a car can be drive, for example, and then brake as well, and then change color and so on. So here we are going to create an example of a class, and then we are going to create an object of that class. So the class that I want to create is going to be called YouTube channel. So in order to create a class, you write class, and then you give a name to your class. So here I'm going to say YouTube channel. like this, and then you put these curly brackets, and at the end you will have to put a semicolon. And now here you will put the members of this class. Now, one thing that I haven't mentioned is that class is user-defined data type. We have already talked about data types in this course, or in C++ for Beginners course, so if you haven't watched that, make sure to do so. I'm going to link it in the description and then here as well. So we have talked about basic data types such as integer, floating point number, and then Boolean, character, double, string, but a class is going to be a user-defined data type, which is going to allow you to represent a real-life object in programming. And in this particular situation, I want to represent a YouTube channel. So let's think of attributes of a YouTube channel. What is something that describes a YouTube channel? Let's say, for example, that each YouTube channel has a name. So that is going to be a string variable. Let's say string name, like this. So these attributes are going to be represented with variables. So one of the attributes is going to be name, and then let's say another is going to be string owner name, like this. And then let's think of another attribute. Let's say that each YouTube channel has a subscribers count. So int subscribers count, like this. And then let's as well create a list of published videos. So I'm going to say list, and let's call it published video titles. So that is going to be type string, and it is going to be called published, like this. Now, here it says that this list cannot be used because we haven't included it here. So here I'm going to say include list, and now this should be accessible. Okay, now we don't have that error anymore. And what I want to do here is I want to represent a YouTube channel that has 4 attributes. It has a name, then owner name, you can use email here or whatever, and then it has subscribers count and published video titles. Now here you can use another class. Here you can say, for example, list of videos. You can create another class that is called video, and then in that video class you can put all the attributes that describe a video. So that can be, for example, a title, and then a description, number of likes, number of comments, number of views, the duration of that video, the video itself, But for the simplicity of this particular example, I'm going to use just the title of those videos. So now, after I have created this YouTube channel class, what I can do is I can create an object of that class. So let's say here that I'm going to create an object. So how you do that, you say the type, so you put the name of your class, which is YouTube channel, and then you give a name to that variable. Let's call it YouTube channel, like this. Okay, now what I want to do is I want to assign values to these properties of my YouTube channel. And how do I do that? Well, you say YouTube channel, and then you put dot. And here is nothing available, but it should be. These properties should be available when you say YouTube channel dot. Now, why these are not available? It is because all the members of your class are by default private. And that means that these members, because they are private, they are going to be accessible only within this class here. And in order to make them public, in order to make them accessible outside of this class, you put public access modifier. So you say here public, okay, like this. Now, this public is an access modifier, and it is going to make all of these members of your class accessible outside of your class, which means that now if I press dot here, as you can see, name, owner name, published video titles, and then subscribers count is available for me now. So I'm going to say that the name of my YouTube channel is going to be, for example, Code Beauty, like this, and then owner name, let's copy this a couple more times. So owner name is going to be my name, so Saldina, like this. and then subscribers count. Well, let's say this is an integer variable, so we don't need the quotation marks. Let's say 1,800 people, and then these published video titles. So let's add value to my published video titles list. So here I want to say that I have published, for example, C++ for beginners. Oh, let's say video 1, okay, and then let's say HTML and CSS video 1, okay, and let's add as well this video. So let's say C++ OOP video 1, okay. Now after I have assigned value to these properties, what I can do is I can write out these properties. So I can say here, for example, cout, and then let's say name, and let's write out the name of my YouTube channel like this. And I'm going to add an end line, and I'm going to copy this a couple more times like this. So here I want to write out owner name. So let's put YouTube channel dot owner name, and then here I want to write out a subscribers count. So YouTube channel dot subscribers count, and then published video titles. Now this property here, published video titles, is not a simple property, meaning this property here is a list, and in order to write out a list we are going to use a loop. So I'm going to delete this, and then here I want to create a loop, and let's say that we will be using for each loop. So I'm going to say for like this, and then here I'm going to write out the type of the value that I'm going to use in my list. So I'm going to say string, because this published video title is of type string, and then here I want to give it a name. So I'm going to say video title like this, and then I'm going to specify the list that I want to iterate, and that list is going to be this one here. So it is going to be a list of published videos in my YouTube channel object, okay. And now in these curly brackets I am going to specify the block of code that is going to be executed in each iteration. So what I want to do with this video title is I want to write it out. So I'm going to say cout, and then let's write out video title, and I'm going to add an end line at the end as well. And one more thing that I want to write out before this list is going to be just cout videos like this, okay. And let's add end line at the end so that it is formatted nicely. So now if I run this program, as you can see, it has written out information about this object that we have created here. It says that the name of YouTube channel is Code Beauty, and then owner name is Saldina, subscribers count is equal to 1800, and then this channel has published 3 videos, so C++ for beginners, and then HTML and CSS video 1, and then C++ object-oriented programming video 1. Okay, so I have created a class that is called YouTube channel. I have created 4 attributes, so 4 properties, and made them public, which means that these 4 properties are going to be accessible outside of this class, and we have accessed those properties here. So we have said that we want to assign value to our name property, and then owner name, subscribers count, and then we have as well assigned value to this published video titles list, okay. And then here we have written out information that is stored inside these properties. So that was an example of how you can create a class, and then how you can create an object of that class as well. And in my next video we are going to be talking about constructors and class methods, because there is a more simple way to do this that we have done here. So make sure to check that video out as well. So I hope that you enjoyed this video. If you did, give it a thumbs up, and also please subscribe to my channel and click that bell icon, and I'm going to see you in my next video. Bye! Hi everyone, welcome to my channel. My name is Saldina and I make IT and programming related videos on this channel. So if that is something that is of interest to you, consider subscribing and give this video a thumbs up as well. And in this particular video, I want to talk about constructors and class methods. So here I have some code that we have written in a previous tutorial of this course. So if you haven't watched that, make sure to check it out. I'm going to link it here and in the description as well. And let's explain very quickly this code that we have here. So I have created a class called YouTube channel, and that class has 4 public properties. So 4 attributes. Those are name, owner name, subscribers count, and then a list of published video titles. And then here I have created an object of that class. I have assigned the value to these properties here. Okay, and then here I have written out information about this object that we created. And as I said, in this video I want to talk about constructors and class methods. And how am I going to explain these? Well, let me first introduce a problem to this approach here so that you can really understand the need for these two. So, what happens if I want to create another object of this YouTube channel class? How am I going to do that? Well, in this current situation, what I would do is I would copy this. So I'm going to copy it and then I'm going to paste it here like this. And let's give it a name. Let's say that this channel is going to be YouTube channel 2. And let's call it, let's say YouTube channel 2.name. Let's say that it is going to be called Amy Sings, for example, and owner is going to be a girl called Amy, and then she is going to have, let's say, 2,000 subscribers. Okay, and then the videos that she has published are going to be songs, obviously, because she has a channel named Amy Sings. So let's say that she has published, for example, let's say Johnny B cover like this. So that's one song, that's one video. And then let's say that another video that she has published is going to be, for example, Lorelei. So that's a song from Scorpions and she has made a cover of that song like this. Now these two are 2 of my favorite songs. And you can put whatever you want here in this list. And I'm also wondering, and you can write that in the comments down below, what are your favorite songs? So please write that in the comments. Just don't put links because I think that YouTube has this policy of treating links as advertising or spam or something. So just write out the name of your song and then the name of a singer, I guess. And I'm really looking forward to reading your comments. So now that I have created this second YouTube channel, what I want to do is I want to write out information about this channel. But I noticed that I'm missing here this YouTube channel 2. So here I'm going to say YouTube channel 2.owner name and then YouTube channel 2.subscribers count and then YouTube channel 2.published video titles as well. Okay, now if I wanted to write out information about this second channel, what I would do is I would copy this. So I'm going to copy it and then paste it here. And here I will say that the name is YouTube channel 2.name and then owner name is YouTube channel 2.owner name and then here as well. And then YouTube channel 2.published video titles. Okay, now if I run this program, we should get information about these 2 channels. So the first channel is this one that we already had. It's Code Beauty, owner is me, and then this is subscribers counter, and then these are 3 videos that I published so far. I mean, I published more than 3 videos, but this is just an example. And then here is our second channel. It's called Amy Sings, and then owner is Amy. She has 2,000 subscribers, and then she has published 2 covers. Now, this here has a problem. If we wanted to create a third, a fourth, a fifth object, we would have to copy this code, and then each time that we want to write out information about those channels, we would have to copy this code. And this really collides with a principle called don't repeat yourself, meaning do not repeat your code if you don't really have to repeat it. And in this particular situation, we do not have to repeat it. So how we are going to solve this problem? Well, the first thing that I want to talk about are going to be constructors. And what a constructor is, it is a special method that is going to be invoked each time that you create an object of a specific class, meaning that method is going to be called on the construction of that object. So there are two rules when it comes to constructors. And the first rule is that constructor has the same name as your class. And then the second rule is that constructor does not have a return type. So let's create a constructor for this YouTube channel class. Here I'm going to say YouTube channel like this, and then I'm going to put these parentheses and I'm going to put these curly brackets as well. Now, what I want to do in this constructor is I want to receive two parameters. I want to receive two arguments, and those are going to be string name and then string, let's say owner name. Okay, now these are two parameters that I want to pass to my constructor, and what I'm going to do with these in my constructor is I'm going to assign these to these properties here. So I'm going to say that name is going to be equal to whatever my user has passed to this constructor. So name is equal to this name here, and then owner name in my class is going to be equal to this owner name that I have received in my constructor. Now, since this constructor here is invoked each time that I create object, each time that it is constructed, that means that at the beginning, when a channel is created, it has 0 subscribers. So I'm going to put here 0 like this. We do not even have to pass this value in our constructor, because when you create your YouTube channel, you do not have subscribers. Okay, now what am I going to do here is I do not need to write this code like this anymore. So I'm going to actually comment this code here. And as you can see, this is underlined. It says that no default constructor exists for class YouTube channel. Now, what we have to do is we have to use this constructor here that I have just created. And how you do that? Well, you put parentheses here, and then inside these parentheses, we are going to pass these two parameters. So the first parameter is going to be the name. So that is the name of our channel, and that is this name here. So code beauty like this. And then a second parameter, as you can see here, is owner name, and that was this value here. So I'm going to pass that here like this. And now, after I have created this YouTube channel, we do not need this code anymore, so I'm going to delete it. Okay, and what we can do is we can do the same with this second channel, so with this YouTube channel too. So I'm going to really comment this code for a moment, and then here I want to invoke a constructor for this YouTube channel class and pass it as first value the name, because we are receiving name as our first value in our constructor like this. And then the second value that we need to pass is going to be owner name. So I'm going to copy that as well. And now we have successfully created this second YouTube channel. Okay, so now I can delete this code here as well. Okay, and now if I run my program, as you can see, it has written out information about my two channels. The first one is Code Beauty, owner is me, and then I have 0 subscribers because I have just created my channel and we have assigned that here. And then our second channel is Amy Sings, owner is Amy, and she has 0 subscribers as well. And as you can see, both of these videos, published videos lists, are empty because we haven't really added any videos. Okay, so how do you do that? I'm going to delete this from here and then move it here like this. So now we have both of our objects being created at the beginning here. So what I want to do now is I want to add a couple of videos to this channel here. So how do you do that? Well, you say YouTube channel like this, and then I'm going to put dot, and here in this published video titles list, I'm going to invoke a method push back, which is going to add at the end of this list another element, and that element is going to be of type string, because this published video titles is a list of strings. So here I'm going to add a string, and I'm going to call that video C++ for beginners like this. So that is one video, and then let's add a couple more videos. Let's say HTML and CSS for beginners. And then let's say OOP for beginners. Well, no, let's say C++ OOP, like this. Okay, so we have added 3 videos for this first channel, and then this second channel does not have videos yet. So if I run my program again, you can see that this first channel has 3 videos, and then this second channel does not have any videos yet, because we have deleted those that we previously had. Okay, now that was the example on how you can create a constructor and how you can use a constructor. So this here is the constructor of this YouTube channel class, and we have passed 2 parameters, 2 arguments to this constructor, and then here in our constructor we have really assigned initial values to these properties here that we have in our YouTube channel. And then this here is the way that you use your constructor. So you put these parentheses, and then you pass the values that your constructor has to receive. And here we have created 2 objects, and we have done that without repeating code. Now what is going to happen with this here? So this here and then this here is repeating code as well. And in order to solve this particular problem, we are going to use class methods. So class method is going to describe a behavior of a class, and since here we are writing out these attributes of our class, since we are writing out information about our YouTube channels, what I want to do is I want to create a method that is going to be called getInfo, for example. So that method is going to be of type void. Let's call it getInfo, like this. And what I want to do in this particular method is I want to copy this code here. So I'm going to cut it and then paste it here. And in this particular method, in this getInfo, I want to say, please write out name and then the name property. We don't need this YouTube channel object anymore because we are in the class itself. Okay. And then here as well, I'm going to delete this here and then here. And now this code should work. So whenever you invoke this getInfo method on your object, it should write out all of these properties of that object. So now I can remove this code here as well. So this information about our second channel, and how am I going to invoke this method? Well, I say the name of my object. So for example, YouTube channel dot, and then as you can see, I have this getInfo method available here because it is public. So I say getInfo and I invoke it like I would invoke any other function. And let's do the same for our second YouTube channel. Let's say YouTube channel 2 getInfo, like this. And now if I run my program, as you can see, it has written out information about my 2 channels. So Code Beauty, Saldina is owner, and then subscribers count, my videos, and then info about my second channel as well. So I hope that you understood the concept behind a constructor of a class and then behind a class method. Here we have demonstrated how you can create an object using a constructor, and then here as well. So you don't really have to repeat your code each time that you create an object. And then here we have invoked a method of these objects, which we have implemented here. So you do not have to repeat that code as well. Each time that you need to get information about your object, you just invoke this getInfo method. And now our main function looks much cleaner, and all the implementations of the construction of our objects, and then this getInfo method are in this YouTube channel class. So I hope that you enjoyed this video. If you did, give it a thumbs up and also subscribe to my channel. Don't forget to hit that bell icon, and I'm going to see you in my next video. Bye! Hi everyone, my name is Saldina and I make IT and programming related videos. So if that is something that is of interest to you, consider subscribing to my channel and give this video a thumbs up as well. And in this particular video, I want to talk about encapsulation. Here I have code that we have written in the previous videos of this course, so if you haven't watched those, make sure to check them out. I'm going to link them in the description of this video. And I'm going to go over this code very quickly so that you can understand what we have written here. So here I have created this YouTube channel class, which has 4 public attributes, and those are name, owner name, subscribers count, and then list of published video titles. And then here we have a YouTube channel constructor, and then this getInfo method as well that just writes out information about our YouTube channel. And here's the code of our constructor. Okay, and then in our main function, we have created an object of this YouTube channel class, and we have assigned it these 2 values for our name and our owner name. And then we have as well added 3 videos to this published videos list. And here we have written out information about our channel. So if I run this code now, as you can see, this is how it behaves. It writes out information about our YouTube channel. Now, what I want to talk about in this video is encapsulation. And what does this principle of encapsulation says? Well, encapsulation says that these properties here should not be public. These should be private, and then the way to change the value, the data that you store inside these properties, should be really using methods that you expose, and then you give access to those methods to your user, and then using those methods, obeying the rules of those methods, your user can change the value of these properties. Okay, so let me introduce a problem here so that you can really understand why we need encapsulation. So what happens if I say, for example, that YouTube channel, so this that we have created, has, let's say, 1 million subscribers. Okay, this is 1 million. Now we have assigned 1 million subscribers to this YouTube channel, and this should not be allowed. If I run this program, you can see that this YouTube channel has 1 million subscribers now, but this is not the natural way to gain subscribers for your YouTube channel. What you should do instead is you should give your user the ability to invoke subscribe and unsubscribe methods, and then using those methods you are going to increase or decrease this subscribers counter. So let's do that. Let's first hide these properties from our user, so from whoever is going to use this class here. So how do you hide these? Well, you make them private. So here, instead of using public access modifier, I'm going to use private access modifier. So I'm going to say private, like this. And then these should stay public. So I'm going to put public here, like this. Okay. And then, as you can see, we have a problem here. It says that this subscribers count is inaccessible, and then this published video titles as well is inaccessible, meaning that we cannot access these private members of our class. These private members can be accessed only within this class itself. So how we are going to give our user the ability to change this subscribers counter? Well, as I said, we are going to create methods. So let's create 2 methods. The first one is going to be void subscribe, like this. And then what this method should do, it should increase this subscribers counter. So here I'm going to say subscribers counter, like this, plus plus. Using this increment operator, we are going to increase the value that we store in this variable by 1. And then we are going to have as well unsubscribe method. So I'm going to copy this, paste it here, and let's say unsubscribe. And then here I'm going to say that this subscribers count is going to be decremented. So now if I will have to comment this code here, and then I'm going to delete this code here. And now if I want to increase or decrease subscribers for my channel, what I will have to do is I will have to invoke one of these two methods. So let's say, for example, YouTube channel dot subscribe, like this. Okay, and let's invoke this method 3 times, for example. And now if I run this program, as you can see, my channel, so Code Beauty channel, has 3 subscribers. And then let's say, for example, that I haven't published videos in a while, so people decide to unsubscribe. So I'm going to invoke this unsubscribe method, like this. And if I invoke this get info after that, I should have 2 subscribers. Well, oh, as you can see, I have 2 subscribers now because 3 people have subscribed and then 1 person has unsubscribed from my channel. Okay, so we have this code here as well that was underlined, meaning that it has compile time error, and it says member published video titles is inaccessible, meaning that now we cannot access this published video titles list anymore because it is private now. So I'm going to expose a method that is going to publish videos for me. So here I want to create a method of type void, which is going to be called publish video, like this. And then here I want to add a video to my published video titles, like this. So I'm going to say published video titles, push back. And then what I want to do is I want to pass a value here. Which value? Well, we are going to receive that value as a parameter in our function. So here I'm going to add an argument, a parameter, and that is going to be of type string. And let's call it title, like this. And now we are going to use this title here. So we are going to push this title in our published videos titles. Okay, like this. Now, if I want to invoke this method, I'm going to invoke it like this. So I'm going to say YouTube channel dot publish video, like this. And then I'm going to do the same thing here, and then here, and here as well. Okay, so now we have created these methods that we invoke, and then using these methods, we change these properties. And these properties should be private, meaning these should be encapsulated. Okay. And now, as you can see, we have a channel called Code Beauty, and then owner is myself, and subscribers is 2, and then these are videos that I have published so far. Now, if you look at this unsubscribe method, you will notice that it has a bug. What is that bug? Well, let's delete these 3 lines of code. Let's delete these subscribe method invocations. And if I run my program now, what is going to happen? As you can see, it says that my subscribers count is equal to -1. And that does not really make sense. So you cannot have -1 subscriber. And we are going to fix that problem if we put here inside this unsubscribe method a check. So we want to check if our subscribers count is greater than 0. And only in that situation, if that subscribers count is greater than 0, only then we can decrease this subscribers count value. So if I run my program now, as you can see, we have invoked this unsubscribe method, but we still have 0 subscribers. And now we have fixed that bug that we had, because if no one has subscribed to our channel, then no one can unsubscribe from it. Okay, so that was a bug that I wanted to fix. And then what you can do here, because here we have exposed these 3 methods that really manipulate the values that are stored inside these properties. And then these 2 properties, there is no way to change them outside of this class. So what you can do for them, for example, is you can create a getter and a setter, meaning a method that is called, for example, getName, and that method is going to return you the value that is stored inside this name variable, and then a setter method, meaning setName method, that is going to receive parameter which is going to be called name, for example, and inside that setName method you are just going to change the value that is stored inside this name property. And then you can do the same for this owner name as well. So you can create a getter and a setter method. So let's go over this encapsulation rule one more time. So encapsulation rule says that all of these properties should be private, meaning they shouldn't be accessible outside of this class, and you do that by making them private. So you put this private access modifier here, and then how do you change the values that you store inside your properties? Well, you expose a public methods that are going to change the data that you are storing inside your properties. And here we have created these three public methods that are going to change the data stored inside our subscribers count property and then inside our published video list property here. So you can, for these two properties, again, you can create getter and setter method. And if some of you do that, please put that code in the comment section and I'm going to review it. So if you enjoyed this video, give it a thumbs up. And don't forget to subscribe to my channel and hit that bell icon as well. And I'm going to see you in my next video. Bye! Hi everyone, my name is Saldina and I make IT and programming related videos on my channel. So if that is something that is of interest to you, consider subscribing and give this video a thumbs up as well. And in this particular video, I want to talk about inheritance. So here I have my Visual Studio and here I have some code that we have written in the previous tutorials of this course. So if you haven't watched those, make sure to watch them. And now I'm going to go very quickly over the code that we have here. So I have created a class that is called YouTube channel, and that class has 4 private properties: name, owner name, subscribers count, and then published video titles. And then we have a couple of public methods as well. We have a constructor, which just initializes these variables here. And then we have getInfo method that just writes out information, the values that are stored inside these properties here. And then as well, we have subscribe and unsubscribe methods. Our subscribe method increases our subscribers counter, and then our unsubscribe method decreases that subscribers counter. But first we have to check if that subscribers count is greater than 0. So those would be subscribe and unsubscribe methods. And then we have this publish video method as well that just adds a new item, adds a new title to this published videos list. Okay, now what is going to happen if I want to create another type of YouTube channel, a specific type of YouTube channel, which is going to be, for example, cooking YouTube channel. So I should copy these properties, right? Well, that can be one approach, but the quicker and better approach is going to be to inherit this YouTube channel class. So let's do that. Let's create another type of channel. So let's create another class. Let's say class, and then let's call it cooking YouTube channel, like this. Okay, now I have created a class that is called cooking YouTube channel, and in order to inherit this YouTube channel class, what I'm going to do is I'm going to put this column sign, and then I'm going to say public YouTube channel, like this. And in this way, my cooking YouTube channel is going to inherit my YouTube channel. And that means that my cooking YouTube channel is going to have everything that my YouTube channel has. Now, this public access modifier means that whatever is public in this class here, it is going to be public here as well. So in this derived class. And one very important thing is to know that this class is called base class, so the one that you inherit from, that is base class. And then the derived class is going to be this one here. So the one that inherits from the base class is called derived class. And in this particular situation, our cooking YouTube channel is derived class. Now, what is going to happen if I want to create, for example, an object of this cooking YouTube channel? So I'm going to say cooking YouTube channel, and let's call it YouTube channel, like this. Okay. Now, as you can see, it says that default constructor of cooking YouTube channel cannot be referenced. Now, that is because we do not have a constructor for this class here. So let's create one. Let's create a constructor. So I'm going to copy this name and then add these parentheses. Okay. And now, if I hover over this, it says that the constructor is inaccessible. So we still have an error, but we have a different error, which means that we are making progress. So because this constructor is inaccessible, I will have to make it public to make it accessible outside of this class here. So I'm going to say public. Okay, and now my constructor is going to be accessible. But there is another thing that we have to do, and that is going to be inside this constructor, we have to receive properties that we are going to initialize in our constructor. And those are going to be these two properties, name and owner name. So here I'm going to say that my constructor receives two properties. So string name and then string owner name. So the owner of that channel. And what I'm going to do when I receive these two properties, I'm not going to initialize them here in my constructor because I'm inheriting from a class that already knows how to construct, how to initialize these two particular properties. So I'm going to call the constructor of that class. So I'm going to call the constructor of this YouTube channel class. So here I'm going to put this column sign, and then I'm going to invoke its constructor. So I'm going to say YouTube channel, and then I will pass these two parameters here. So I'm going to say name and then owner name, like this. And now our base class, our YouTube channel class, is going to construct, to initialize actually the value of these two properties. And as you can see here, we have an error that asks us to pass these two values to our constructor. So we are going to pass two parameters. The first one is going to be the name of our channel. So let's say that that is going to be, for example, Amy's Kitchen, like this. And then owner is going to be girl named Amy. Let's put that here as well. Okay. Now, after I have created an object of this cooking YouTube channel, what I should be able to do is I should be able to access all of these public methods that my base class has. So all of these methods from my YouTube channel class should be available for my cooking YouTube channel. So here I'm going to say YouTube channel dot, and then as you can see, these are available. So get info, publish video, subscribe, unsubscribe. Let's write out info about my channel like this. And if I run it now, well, you can see that we have Amy's Kitchen channel. Owner is Amy. It has 0 subscribers and it has no videos as well. So let's publish a couple of videos for Amy's Kitchen channel. So here I'm going to say, okay, before this get info function, I'm going to say YouTube channel dot, and then let's say publish video of, for example, apple pie, like this. And then let's publish another video, let's say, for example, chocolate cake, like this. And now if I run this program, as you can see, we have two videos. And let's as well say that people like these videos, so they decide to subscribe to Amy's Kitchen channel. So I'm going to say YouTube channel dot subscribe. So for example, 2 people decide to subscribe to her channel, and if I run my program again, you can see that now we have 2 subscribers as well. So we have been able to invoke all of these methods that are implemented in our base class. So here, from the object of our derived class, so from the object of this derived class here. Now this derived class, this cooking YouTube channel, can have its own members, meaning things that are specific for this class only. So let's say, for example, that we want to create a method that is going to be called, for example, practice. So I'm going to say void practice, like this. And then what this method should do, it should just make our user that has this cooking YouTube channel, it should say that this user is practicing cooking and then learning new recipes and things like that. So I'm going to say cout, like this. And then let me copy this part of the code because I don't want to make a typo, like this. So it says that our YouTube channel's user is practicing cooking, learning new recipes, and then experimenting with spices, because I guess that's something that you should do if you have a cooking YouTube channel. And let me add end line here as well, like this. So now if I decide to invoke this method is going to be available only for objects of this cooking YouTube channel. So I'm going to say YouTube channel, like this, and then let's say practice, like this. Now, let me very quickly change the name of this YouTube channel object because I want to create another object that is going to be of this YouTube channel type, and I want to call that YouTube channel. So here I'm going to say cooking YouTube channel, and I'm going to paste that name here, and then here, and here as well. Okay, now we have named this object cooking YouTube channel, and if I run this program, you can see that at the end it says practicing cooking, learning new recipes, experimenting with spices. Now, as I already said, this practice method should be available only for the objects of this cooking YouTube channel class. So that means if I decide to create an object of this class here, this base class, that class is not going to have this practice method. And let's prove that very quickly. So here I'm going to create an object of YouTube channel class type, and let's call that object YouTube channel. That's why I changed the name of this object, like this. And let's say that that is going to be my channel, for example, code beauty, like this. And then let's say that owner is my name, Saldina. So now if I try to access this practice method on my YouTube channel, so I press dot, you can see that that method is not available for this base class. It is available only for this cooking YouTube channel class, because this practice is very specific method, meaning this Code Beauty channel, which is oriented to programming and IT, does not really benefit from learning recipes and experimenting with spices, practicing cooking and things like that. So this channel should probably have some other way of practicing because it is different type of channel. So I'm going to delete this code here. Okay, and let's repeat this one more time. So we have created a derived class which is called cooking YouTube channel, and we have inherited everything that our YouTube channel class has by saying public and then the name of our base class, and this public access modifier is going to allow us to have whatever is public here to have that public here as well. And then we have created a constructor for our cooking YouTube channel, and in that constructor we receive 2 parameters, name and owner name. And since our base class constructor knows how to initialize those 2, we have here invoked this base class constructor. And then here we have created as well a method that is called practice, and that method just says that our user is practicing cooking and he is learning new recipes and experimenting with spices. Now there's one more thing that I want to show you, and that is going to be let's create another object of this cooking YouTube channel, and that is going to be let's say cooking YouTube channel 2, and let's call it John's Kitchen, like this, and owner is going to be, for example, John. Now what is going to happen if I say, for example, that this second YouTube channel, so this cooking YouTube channel 2, John's YouTube channel, is practicing? I'm going to comment these two because I don't need them. And if I run my program now, you can see that it says 2 times practicing cooking, learning new recipes, experimenting with spices, and then the same line here. So you cannot really differentiate between which one is Amy's channel and which one is John's channel. So in order to make that a bit more understandable, I'm going to add a property here. So here I want to add the name of the owner of this channel. So here I'm going to say, let me copy this property like this. So owner name, and then let's say that that owner is practicing cooking, learning new recipes, experimenting with spices, and so on. But as you can see, this property here is not accessible. It says that member owner name is inaccessible. And why is that the case? Why is it inaccessible? Because it is private, and if you remember, private members can be accessed only within that class, and then public members can be accessed from outside of that class. But what happens if you want to have, for example, a certain property to be accessible in the derived class? Now there is an access modifier for that as well. So that is going to be protected access modifier. So I'm going to say here protected, like this. And then I'm going to move this owner name to my protected area, like this. So now this owner name property should be accessible in derived classes as well. And as you can see, the error has disappeared. So now if I run my program, you can see that it says that Amy is practicing cooking, learning new recipes, and experimenting with spices. And then this second line here says that John is practicing cooking and learning new recipes and experimenting with spices. So now we have made a difference. We have specified the name of our owner of the channel, and we can understand what the code is doing a bit more. I hope that you understood what is inheritance and how it works in C++. And if you did, please like this video. Don't forget to subscribe to my channel and click that bell icon as well. And I'm going to see you in my next video. Bye! Hi everyone, welcome to my channel. My name is Saldina and I make IT and programming related videos. So if that is something that is of interest to you, consider subscribing to my channel and give this video a thumbs up as well. And in this particular video, I want to talk about polymorphism. Now, the first thing that I want to do is I want to explain what is polymorphism. Polymorphism describes the ability of an object, for example, to have multiple forms. Now, that means that you can have 2 or more objects that inherit from the same base class. Those objects can have the method that has the same name but different implementation, meaning different behavior. And I'm going to demonstrate that on an example. Now here I have some code that we have written in my previous courses, so if you haven't watched those, make sure to do so. The links to those videos are going to be in the description. And I'm very quickly going to go over this code. So here I have created a class that is called YouTube channel. That class has 3 private properties: name, subscribers count, and then published video titles. And then it has 1 protected property, which is owner name. Now, this private properties, these are available only in this class, and then these protected properties, these are available in derived classes as well. And then here we have public methods as well. And this here is our constructor, so it just initializes values of these properties. I'm going to collapse that. And then here we have getInfo method, which just writes out information about our YouTube channel. And then these subscribe and unsubscribe methods, these just increase or decrease the number of our subscribers. Let's collapse that. And then publish video method, it just adds another video to this published video titles list. So that would be our YouTube channel base class. And then here we have cooking YouTube channel, which is a specific type of YouTube channel that inherits from this base class here. And that cooking YouTube channel has its own constructor, which is this one here. And here we have just invoked the constructor of our base class. And then here we have implemented a method which is called practice. And it says that when you practice and you have a cooking YouTube channel, you will have to be practicing cooking and then learning new recipes and experimenting with spices. Now, what I want to do is I want to create another derived class. So I'm going to copy this. Okay. And then this derived class should be called, for example, let's paste the name here. So Singers YouTube channel, and I'm going to paste the name here as well on my constructor. So this is going to be a YouTube channel about singing. Now, as you can see, this Singers YouTube channel has this practice method as well, but this implementation is not right for my Singers YouTube channel, because if you're a singer, you are not going to benefit really from practicing cooking and then from learning recipes and experimenting with spices. But what you should do instead is you should practice something else. So I'm going to copy that so that I don't make a typo like this. So someone who is trying to make a Singers YouTube channel is going to take singing classes and then learning new songs, and then he should as well be learning how to dance, because I believe that singers should know how to dance as well. Okay, so now we have implemented this Singers YouTube channel, and as you can see, as I already demonstrated, it has this same method, which is practice, but this method has different implementation than this one. And as you can see here, this is the implementation of our practice method on our cooking channel, and then this here is the implementation on our Singers YouTube channel. So what I want to do now is I want to create this Singers YouTube channel. Here we already have cooking YouTube channel. So it is a video, it is a code from one of my previous videos. And then what I want to do is I want to create Singers YouTube channel. So let's call it Singers YouTube channel, and let's say that it is going to be called, for example, John Sings, like this, and then owner is going to be a guy named John, like this. Okay, now after I have created this cooking YouTube channel and then this Singers YouTube channel, you can probably call it singing YouTube channel or something like that. This is the best name that I could come up with. Okay, so now what I want to do is I want to invoke methods on these two classes, and the methods that I want to invoke are going to be these two, so practice and then this practice method as well. So here I'm going to say cooking YouTube channel dot practice, like this, and then let's invoke the same method for my Singers YouTube channel, like this. And now if I run my program, as you can see, it says that Amy is practicing cooking, and then John is taking singing classes and learning new songs and learning how to dance. I can imagine that. Okay. Now, after I have invoked these two methods, you can really see, oh, I have stopped my program, I'm sorry. So here you can see that this cooking YouTube channel has invoked its own method. So this cooking YouTube channel has invoked the method that has been implemented in this cooking YouTube channel class, which is this one here. And then this invocation, so this Singer's YouTube channel, when you invoke practice method on that, this method here is going to be invoked. So this method that is implemented in Singer's YouTube channel class. Now let's add another thing, and that is going to be here in this practice method, and then in this practice method as well. What I want to do is I want to say that each time that our user practices cooking and then practices singing, what is going to happen is the quality of that YouTube channel is going to increase. So in order to track that quality content rating, I'm going to create a property, and that is going to be here in this YouTube channel, in this base class. So I'm going to make that property protected because I want to have it accessible in my cooking YouTube channel and then in my Singer's YouTube channel as well. So I want that property I want to access that property from my derived classes, and because of that, I'm going to make it protected. So here I'm going to say int, and let's call it content quality, like this, okay? And initially, I want to set the value of this content quality variable. In this constructor here, I want to set it to 0, like this, because I want to say that when you create your YouTube channel, this constructor here is going to be invoked, and you are going to have 0 subscribers, and you are going to have a 0 knowledge about content quality. So your rate, content quality rate, is going to be 0. So let's close that. And then what I want to do here in this practice method is I want to say each time that you practice, your content quality should increase. So let's increase that variable. Content, where is it? Content quality plus plus. So I'm going to increment that content quality, and then I'm going to do the same here, like this. Now let's say, for example, that my this singer here, John, he is going to practice a lot. So he has practiced 5 times more than Amy did. So if I run my program now, you can see that John is practicing, and then again and again and again. So he is practicing a lot, and Amy is not really. So what do I want to do with this content quality property? Well, let's say that I want to implement another method, and that method is going to be as well implemented here in this base class, and that method is going to be called check analytics, because that check analytics method should be available for all YouTube channels. So that is not something that is specific for this cooking YouTube channel only, or for this singing YouTube channel, so Singer YouTube channel, but that method should be available for all YouTube channels, and because of that, I'm going to implement it in this base class. So let's say void check analytics, like this, okay? And now what I want to do in this check analytics method is I want to use this property, this content quality property, in a following way. So I want to say if content quality is less than 5, I want to write out a message to my user. So I want to say cout, and then let's write out the name of this YouTube channel, like this, and then let's add a message which is going to say, let me copy that. Okay, this is going to say that this channel has a bad quality content because this content quality has a rating that is less than 5. And let's add end line. And then what is going to happen if this content quality is not less than 5? So if it is equal to 5 or greater than 5, I'm going to put else block here. And what I want to say here, okay, is that this channel has a good content, great content actually. Okay, like this. Now, what am I going to do with this check analytics method? Well, I'm going to try to invoke it here. But the way that I want to try to invoke this this method that we just implemented is going to be in a following way. So there is one very interesting thing when it comes to polymorphism, and that thing is related to pointers. At this point, I haven't made videos about pointers on my channel, but if you're watching this video sometime in the future, then those videos are probably available on my channel, so make sure to look for them on my channel and then in the description of this video as well. So let's create a pointer, and that pointer is going to be a pointer of our base class, so a pointer of type YouTube channel, okay, like this, and let's call it YouTube1. And what I want to do is I want to assign to this pointer here address of this cooking YouTube channel, and you can do that. You can assign to a pointer of a base class an address of derived class. So I'm going to say here, please, to this pointer, assign address of this cooking YouTube channel class, like this. And then what I want to do is I want to create another pointer. Let's call it YouTube2. And then to this YouTube2 pointer, I want to assign the address of my singer's YouTube channel, like this. So one more time, a pointer of base class can point to a variable of derived class. Now, what I can do using these pointers is I can invoke method that I have just created, which is this one here. So check analytics. So let's do that. Let's say YouTube channel 1, and then let's invoke this method. Let's say check analytics, like this. And if you just noticed, it has changed my dot to this symbol here, because this is used when you want to invoke methods using pointers. So I'm going to copy this again for my second YouTube channel, like this. And now if I run my program, as you can see, our John has been practicing a lot, and then Amy has been practicing only one time. So here, after I have invoked these two methods, this first method says that Amy's kitchen has bad quality content because she hasn't been practicing enough. And then after this YouTube channel 2 check analytics, you can see that it writes out this message that John Sings channel has great content because he has been practicing a lot, as you can see here. Okay. So here we have used polymorphism in order to implement this practice method in our cooking YouTube channel and then in our singers YouTube channel. So implementation of our singers YouTube channel practice method is here, and then for our cooking YouTube channel our practice method looks like this. And we have done that thanks to the polymorphism, so different implementations but the same method name. And then I have demonstrated here how you can use pointers to point to an object of derived class, and you can store that in a pointer of base class. And then we have invoked this check analytics methods using these pointers of base class. So I hope that you enjoyed this video. If you did, give it a thumbs up, and don't forget to subscribe to my channel, click the bell icon as well, and I'm going to see you in my next video. Bye! Hi everyone, welcome to my channel. In this video I want to talk about pointers, so I will go straight to the point. Pointers are a very important concept in C++, and they have many uses in C++. Now, pointers are not limited only to C++, they exist in other programming languages as well, but in most of those programming languages they are really hidden, they work behind the scenes, so you cannot see them and you cannot use them yourself. But in C++, you can use them and you can create your own pointers, and they can be pretty powerful if you know how to use them, but they can get quite confusing as well if you don't understand them well. So the first thing that I want to explain is what are pointers. So we already have explained the concept of a variable, and you should be familiar with that. So we said that a variable is just a container, so a container that stores certain value. Now a pointer is container as well, but instead of storing value, pointer stores an address, so a memory location. And let me show you how pointers work in Visual Studio. Let's create a variable of type int, and I'm going to call it n and assign it a value of 5. And let's write out this n like this. So nothing new here, we are already familiar with this, and if I run my program, as you can see, we get this value of 5, so that was expected. Now, as I already said, this n is a variable, and that means that it is a container which is storing certain value. Now, because it is a container, that means that it has its address inside memory, so it has its physical location. So how can we get that location? How can we check which address this n has? So in order to do that, you use this ampersand symbol like this. So you put it before your variable name, and that should give you the address of that variable. So if I run my program now, as you can see, now we have an address, and this is the address of our n variable. So this is its physical address where this value of 5 is stored. And because this is pretty hard for humans to remember, this is just a random numbers and characters. Because of that, we use meaningful names, and we access these values that we store in our memory using these meaningful names, which are our variables. So I'm going to close this now, and what I want to show you here is I want to show you how can you create a pointer that is going to hold this address of our n variable. So in order to create a pointer, you give it a type first, so you say int, and then in order to indicate that you are creating a pointer, you use this star symbol, and then you give it a name, so let's call it PTR pointer, and I'm going to assign it the address of our n variable. So I'm going to copy this and paste it here. Okay, now our pointer is holding the address of our n variable, and in order to prove that, I'm going to write out the value of my pointer like this. So as expected, we have this first line here, which is writing out the address of our n variable, and then this second line of code is this line here, and as you can see, we have written out the value of our pointer, and that is the same address as this one here, which means that our pointer really is storing the address of our n variable. Now, you may ask, how can I access, or can I access the value that is stored on that address using pointers? And the answer to that question is yes, you can. And in order to do that, in order to access the value that is stored on this address that your pointer is holding, you have to dereference your pointer. So how do you do that? Well, let me copy this. So as you already have seen, this line of code here is going to write out the address, and in order to write out the value on that address, you dereference the pointer, and in order to do that, you add this star symbol before your pointer's name. So if I run my program now, as you can see, in this last line of code, we have the value of 5, which is actually the value that is stored on this address here. So let me show you one more thing. What I want to do is I want to change the value that is stored on this PTR address, so on this address that our PTR pointer is storing. So how am I going to do that? I'm going to say, again, star symbol and then PTR, and this here means please access this memory location. So whatever I'm going to assign here is going to be stored on that memory location, and what I want to assign is, for example, value of 10, like this. So now if I copy this line of code and then paste it here, and if I run my program again, we have this value of 10 stored on this address here. And one interesting thing as well is that if we try to write out the value that our n holds now, like this, if I run my program, as you can see, our n holds the value of 10 as well, even though we have never said that n has the value of 10, but we have stored the address of our n in our pointer, and then we have dereferenced our pointer, meaning we have changed the value on that address here in this 11th line of code here. So that's why our n holds value of 10 now. One very important thing to keep in mind is that your pointer has to be of the same type like the variable that it is pointing to. So let's close this. So as I said, this integer pointer is pointing to an integer variable. So our n is of int type. And the same way would be if we created a float pointer, it would have to point to a float variable, and then char pointer can point only to a char variable, double, bool, and so on. So pointer and the variable that that pointer is pointing to have to be of the same type. Okay, so that means that if I try to change the type of this n variable to float, for example, like this, so if I say float, immediately we get an error here, and the error says a value of type float pointer cannot be used to initialize an entity of type int pointer, meaning you cannot assign address of a float type to pointer of int type. Okay, so that is the error that we have here, and I'm going to return this to int. Okay, and as you can see, that error has disappeared because now our pointer is pointing to the same type, so to the variable of the same type that that pointer has. So int pointer pointing to an int variable. One thing that beginners very often try to do is the following. So they say, okay, let's create a pointer. So int, let's give it a name ptr2, so pointer, like this. So I have created a pointer, right? So let's dereference this pointer and assign it a value. So I'm going to say, please dereference ptr2 and assign it a value of 7, for example. Now, this code here has a problem. And if I run it, if I say build solution, actually, as you can see, it says uninitialized local variable ptr2 used. This means that this ptr2, so this pointer 2, does not have an address. So where should it store this value of 7 if it does not have an address? And the easiest way right now to solve this problem is going to be to create a variable and to give the address of that variable to our ptr2 pointer. So I'm going to say int v. This variable has to be of the same type as our pointer, as we already said. And then I'm going to say here our ptr2 is going to hold the address of our v variable, like this. And now we shouldn't have this problem anymore. So if I build my code again, as you can see, one succeeded, so the problem has disappeared. And let me write out the value of this v variable. So I'm going to say v is equal to, and then let's write out the value of this v. And if I run my program, as you can see, it says that v has the value of 7 because we have assigned it here by dereferencing our pointer that is holding the address of our v. So you may say now, okay, Saldina, I understand this, but this seems a little bit too much. Why would I create a pointer just to assign a value to a variable? And the answer to that question is you don't. This is not the type of problem for which pointers were created in C++. So there are different problems that pointers solve in C++, and this here is just a demonstration of what are pointers and how can you create your own pointers. Now, examples of some of these other problems that pointers solve is you can use pointers in order to pass values by a reference to a function, and then you can use them to return multiple values from a function, which is an interesting one. You can use pointers in combination with arrays as well. You can use them for dynamic memory allocation. And then if you're familiar with OOP, object-oriented programming, you can use a pointer of a base class in order to access an object of derived class. And then there is this concept of smart pointers, which we are going to cover in the future. So I believe as well that I have mentioned some of these things in some of my videos, but I plan to make a dedicated series to pointers where we are going to talk only about pointers. So stay tuned, subscribe to my channel, hit that bell icon as well so that you are notified when I publish my next video. And if you like this one, give it a thumbs up. Thank you for watching, and I'm going to see you in my next video where we will be talking about pointers. Bye! Hi everyone, welcome to my channel. In this video I want to talk about void pointers. Now, in the previous video of this playlist, I introduced you to pointers in general, so I explained what are pointers and how you can create your own pointers. And I said that a pointer is a special variable that can hold an address. And I said as well that a pointer can hold only the address of a variable that is of the same type as that pointer, which means an integer pointer can hold the address of an integer variable, and then a character pointer holds the address of a character variable, float pointer of a float variable, and so on. But there is an exception to that rule, and that is a void pointer. And a void pointer is a special type of pointer that can hold the address of a variable of any other data type. So a void pointer can hold the address of a float variable or an int variable or a char, bool, struct, whichever one you pass to that void pointer. But a void pointer has a limitation as well, and that limitation is that you cannot directly dereference a void pointer. So in order to demonstrate this, I'm going to create an example with the knowledge that we already have, so using only integer and character and float pointers that we are already familiar with, and then I want to introduce a void pointer in order to solve that problem so that you can see how void pointers are used. So let's jump into our Visual Studio. Here I want to create a variable, and let's make it of int data type. So I'm going to say int, and let's call it number, like this. And I'm going to assign it a value of 5, for example. Now, what I want to do with this number variable is I just want to write it out. And because we are working with pointers, let's play with pointers some more. So I want to write out this variable using a function that receives a pointer. Let's do that. So that function is going to be of return type void, and let's call it print number, like this. And then here, this function is going to receive an integer pointer, and we are going to call it number ptr, so number pointer. Okay, now what this function here should do is it should just print out the value that this number pointer is storing. So actually the value that is stored on the address that this number pointer is holding. So in order to do that, we have to dereference this pointer. So I'm going to say star symbol and then put the name of this number pointer, and let's add an end line as well. Now this function is finished, and it is writing out the value that is stored on the address that we pass to it, and we have to pass it the address of an integer variable. So if I invoke this print number function, let's say print number, as I said, since it is receiving a pointer, we have to pass it an address, and that is going to be the address of this number variable. So let's say ampersand number. So this here is going to give us the address of this number variable. Okay, and now if I run this program, as you can see, this function here has printed out value of 5, which is the value of our number. Okay, now what happens if I want to create a character variable and then print out a character variable as well? So let's do that. I'm going to say char, let's call it letter, and let's assign it a value of a letter A. Okay, and now in order to print out this character using this same approach, I will have to create another function because this one here receives an integer pointer, and in order to print out a character, we would have to create a function that receives a character pointer. So let's copy this function here, and I'm going to call it print letter, like this. And then this function is going to receive a character pointer. Okay, and that pointer is going to be called char ptr. And then here I just want to write out the referenced value of that char ptr. So let's invoke this print letter function. Let's pass it the address of this letter variable that we have created here. And now if I run this program, as you can see, we have 5 for this first function and then a for this second function, which means that these two functions are doing its job. But what happens if I want to print out a floating point number and then a double and then a Boolean value and a struct value? In order to do each one of those, I would have to create a function that receives that specific data type pointer. But we can solve that same problem using a void pointer, because as we already said, a void pointer can point to a variable of any data type. So let's do that. Let's create a function that is going to print out any data type. So that function is going to be of return type void, and let's give it a name print. Because it is generic, it is going to work with all data types. I'm going to give it name of print, and as we said, that function is going to receive void pointer, and let's call that pointer ptr. Okay, now because this void pointer can point to a variable of any data type, we will have to keep track of which data type we have passed inside this void pointer. And in order to do that, I'm going to use another parameter here, and that parameter is going to be of type char, and I'm going to call it type. So how this type parameter is going to be used? Well, in a situation where we pass an integer pointer to this print function, here this type parameter is going to have a value of I. In a situation when we pass a character pointer to this void pointer here, in this type parameter we are going to pass a value of C. And then if we pass a float pointer here, we are going to store an F. And then if we pass a double pointer here, this type variable should store a letter D, so that we can know how we are going to dereference this PTR pointer. So the first thing that we have to do is we have to check what this type variable is holding. So in order to do that, I'm going to use switch case like this. You can use if else as well if you want. So here I'm going to switch on this type variable like this, and what I want to do here is I want to say, in the case that this type variable is holding the value of I, that means that this here is an integer pointer. So here I'm just going to leave a comment for now. So I'm going to say handle int pointer like this. And then the other situation is going to be, in the case that this type variable is holding the value of C, that means that here we have passed a character pointer. So I'm going to leave another comment as well. So here I'm going to say handle char pointer. Okay, now let's explain how we are going to handle this integer pointer and then this character pointer as well. Well, as we already said, since a void pointer cannot be dereferenced directly, but we first have to cast it into a specific data type, so into an integer pointer or into a character pointer in this particular situation, I'm going to do that. So here I'm going to say, in the case that our user has passed an integer pointer here, I will have to cast this void pointer into an integer pointer first. So how do you do that? Well, you say, please, this pointer here, so this PTR, cast that into an integer pointer. So this expression here is going to cast this void pointer into an integer pointer. So in these parentheses here, we are going to have an integer pointer, and in order to access to the address that an integer pointer is storing and write out the value that is stored on that address, we dereference that pointer, and for that we use this star symbol. So now here we have the value that is stored on this integer pointer, and I'm going to write out that value like this, and let's add end line as well. So this here writes out the value of an integer pointer. So let's copy that and then paste it here. And here what I want to do in this C situation is I want to cast this void pointer into a character pointer, so char pointer, and then after I have character pointer here, I dereference that, and then this line is going to write out the value of our character. Okay, so now if I invoke this print function, I should get the value of this number and then of this letter as well, using only this print function. So let's comment these two for now. And let's invoke our print function. So I'm going to say print. And then the first thing that it receives is going to be the address. And in this particular situation, considering that this is a void pointer, we can pass it the address of any data type. So we can pass it the address of a integer variable or of a character variable or of a floating point variable. And in this situation, we have integer variable and then character variable. So let's use these two. So let's pass here the address of our number. That is going to be the first parameter. And then the second parameter is going to be the type. And considering that we have passed the address of an integer, let's pass the value of I as our second parameter here. Okay. And then I'm going to copy this function one more time. And this time I want to pass it the address of our letter variable. And considering that that is a character, here as a second parameter, I'm going to pass C. Now I've just noticed that something is missing from our switch case. And before I say what it is, please write your idea, write your answer in the comments down below. So what we are missing in these two cases is break at the end. So here I'm missing a break like this, and then here as well. Okay, so now we have completed our switch case, and if I run my program now, as you can see, for this first line we get the value of 5, which is our integer. So this print function has printed the value of our integer, and then in this second line we have printed out the value of a character, and we have done that using this print function, which receives a void pointer, and then it receives a char variable which is called type, and we use that char variable in order to differentiate which data type we are storing inside this void pointer. Because, as I already said, a void pointer can point to a variable of any data type, but it cannot be dereferenced directly. So for that we are using this type parameter to check which data type is stored inside this pointer here. So now you have an idea on how to use void pointers, but I would actually advise you to be very careful when using void pointers. Why? Because your compiler in this particular situation does not have a way to tell you, hey, you are trying to cast a void pointer, which is actually an int pointer, into a character, or vice versa. If you're doing that, your compiler in this situation here does not have a way to know if you are making an error or not, because inside a void pointer you can store the address of any variable, so of a variable of any data type, and then you can try to cast that void pointer into a pointer of any other data type, which means, for example, in this particular situation, here we are passing an integer. So this number here is an integer, which means that here for this line of code, we are receiving an integer pointer. Okay, and then in this case here, we are trying to cast that into an integer pointer, and that is okay. But if we accidentally make a mistake here and we try to cast that into a character pointer, for example, like this, our compiler now does not have a way to know that we are making a mistake here. And if we run our program, look at this. We get this undefined symbol here, which is, what is this? You know, this is not the expected behavior of our program, and we did not get a compile time error, which means that this here is completely valid. So your compiler is not going to tell you that this here is an error, but it actually is a logical error. And those type of errors, so logical errors, are much harder to find inside programs. And this here is a small program, and it is kind of easy to find an error in a program that has 20 lines of code. But if you had a logical error in a program that has 20,000 lines of code, for example, you would have a very, very big problem. So again, I strongly advise you to be very careful when you are using void pointers, because as you see, compiler is not reporting an error for this situation here, but this actually is an error. So I'm going to return this to an integer pointer. Okay, so I hope that you enjoyed this video and that you learned something new. And if you did, give it a thumbs up, subscribe to my channel, and thank you for watching. I'm going to see you in my next video. Bye! Hi everyone, welcome to my channel. In this video, I want to talk about pointers and arrays, and if you watched the first video of this playlist, you remember that I said that one of the common uses of pointers is using them with arrays. So in this video, I want to demonstrate how that works. So let's jump straight to our Visual Studio, and let's create an array of type int, and I'm going to call that array lucky numbers. Like this, and let's say that I have 5 lucky numbers, for example, and those are 2, 3, 5, 7, 9. Oh, that's 5 numbers already. Okay, so these here are my lucky numbers, and now I want to show you one thing. So what is going to happen if I say, for example, cout lucky numbers, and let's add end line. So what is going to be written out if I write out just the name of my array? Let's check that. If I run this program, as you can see, we get an address. But what is this address? This address here, so the name of our array is actually the address of the first element of that array. And in order to prove that, let's write out the address of the first element of this array to check if these two are going to be the same. So here I want to write out the address of the first element, which is the element with index 0. So now if I'm telling the truth, these two should be the same. So if I run my program, as you can see, indeed, we get the same address, which means, again, the name of the array is the address of the first element of that array. Now, that means that this lucky numbers name behaves as a pointer, and these square brackets here are behaving as an operator for dereferencing. So if I say, for example, cout lucky numbers of 2, I'm going to get the element that has index 2. So this here is going to be the first address, and then it is going to add 2 more addresses to that element, and we are going to get the value that is stored there. So lucky numbers name is the address of the first element. It is going to add 2 more addresses to that, so 1, 2. So this line of code here is going to give us the value of 5. Let's add end line and run our program in order to demonstrate that. And as you can see, indeed, we get the value of 5. Now there is another way to do this same thing here, and that is going to be the following way. So I can say cout, please write out this lucky numbers, which, as we already demonstrated, is the address of this first element. So I'm going to put that here. And then I can use arithmetic operators on this. So I can say, please add to this lucky numbers 2 more address spaces, and then dereference this. So we use star symbol for that. And then I'm going to add end line and these 2 lines of code. So this one here and this one here should behave the same. So if I run my program now, as you can see, we get the same value. So these 2 lines of code are doing the same thing, which means that this line of code here is using these square brackets in order to dereferentiate the element with that index, which is index 2. And we know that the indexing starts with 0, so 0, 1, 2, and we get the value of 5. And then this second line of code here uses this star symbol in order to dereferentiate this expression here. And what this expression here says, it says lucky numbers, which is the address of the first element, as we demonstrated here. So please use the address of the first element and then add 2 more address spaces to that. So the address of the first element, if I add 2 more to that, it's going to be the address of 1, 2, so the address of this one here, and then if I dereferentiate that, I get this value which is stored on that address. So these two lines of code are writing out the same thing. So let me very quickly show you how you can enter the values for this array and then write them out, because here we have hard-coded values. So I'm going to delete this, and I'm going to comment these two lines of code as well. No, actually I'm going to comment all of these because we don't need them anymore, but I'm going to leave them for you so that you can see how these are used in order to dereferentiate your array. So as I said, we want to enter values for our array now. So in order to do that, I'm going to use for loop. So I will say for, and then our for loop starts with I equal to 0, because that is the index of our first element. And then, considering that our array has 5 elements and the last one has index of 4, we are going to run our for loop while I is less than or equal to 4. And in each iteration, we are going to increment the value of our I. Okay, and in order to enter values for our array, let's write out a message. So I'm going to say cout number, so please enter a number. That is going to be the message for our user. And then I'm going to input a value from my console into lucky numbers of I. So this here means please enter the value into our lucky numbers array to element that has the same index that our I holds in that iteration. So in the first iteration, index 0, in the second iteration, index 1, and then in the third iteration, index 2, and so on. So this for loop here is going to help us to enter the values into our lucky numbers array. And in order to show that, I'm going to put here a breakpoint, and that means that our program is going to stop its execution when it comes to this line here. So if I run my program, as you can see, it asks me to enter a number. So I'm going to say 2, 5, 7, 9, and 13. So those were 5 numbers that we had to enter for our lucky numbers array. And if I press enter one more time, as you can see, our program has been stopped in this line of code here. And if I hover over my lucky numbers, here we have values that we have entered for our array. So value of 2, 5, 7, 9, and 13, which are the values that we have entered here. So I'm going to stop my program now. Please stop. Okay. And now what I want to do is I want to use this other approach to write out the numbers that this lucky numbers array is holding. So let's use another for loop. I'm going to copy this one. Okay. And then what this second for loop is going to do, it is just going to write out these numbers. But, okay, let's use this approach for now. So I'm going to just change this to cout and then use these other redirection signs. And after each number, I'm going to add an empty space. Okay, like this. And instead of using this approach here, so instead of using these square brackets in order to dereferentiate the element on that position, let's use this approach here. So I'm going to say, please use lucky numbers, so which is the address of the first element, and then to that I want to add the value of my I, so plus I, like this, and this is going to move. Okay, so this expression here is going to help us to access all of the elements of this lucky numbers array. So from the one that has index 0 until we come to the one that has index 4. And because we don't want to write out addresses, because this here is going to give us the address, but we want to write out the values that are stored on those addresses, we will have to dereference this expression here. So for that, I will use star symbol. And I'm going to remove this breakpoint now, and I'm going to start my program to see what is going to happen. Okay, and let's enter 2, 3, 5, 7, 19. And as you can see, we get values of 2, 3, 5, 7, and 19, which we have entered. Okay, let's stop this program now. And there is one more thing that I want to show you. What is going to happen if I change this max value from 4 to 5, like this? So what is going to happen in this particular situation? Let's run our program and enter numbers again. So 2, 5, 7, 13, 15. Okay, as you can see now, here we have these 5 numbers that we have entered. So 2, 5, 7, 13, 15. Those are the ones here. And then the last one is something that we do not recognize. What is this? This is some junk number that we definitely have not entered here. So this number here is something that does not belong to our lucky numbers array. And here we have accessed someone else's memory space. So we have this result because we changed the max value from 4 to 5 here. And as we already know, our lucky numbers has 5 elements. The last one having the index of 4, which is this one here. And then here we added one more iteration. So now we are trying to access the element with index 5. And that element with index 5 does not belong or does not exist in our lucky numbers array. So this element here, this is memory location that belongs to someone else. And we accessed that trying to dereferentiate the pointer to the element that is 6th element. So we have 5 elements in our lucky numbers array, and then if we add one more address space to that, we get this here, which is memory location that belongs to someone else. And if we just randomly change and access memory locations that do not belong to us, we can cause very, very big problems. So I advise you to be very careful when iterating through your arrays and to access only memory locations that belong to that array that you are iterating. So in the case that your array has 5 elements, those are going to be from 0 to 4, so indexes from 0 to 4. In the case that your array has 10 elements, for example, those are going to be indexes 0 to 9, and so on. So again, be very, very careful to not access memory locations that do not belong to you. So I hope that now you have an idea on how pointers and arrays go together, and as well we have seen some of the potential problems that can happen if you are not careful enough when working with pointers and arrays. So again, I advise you to be very careful when working with pointers and arrays and not access memory locations, memory addresses that do not belong to you. So thank you for watching this video. If you enjoyed it, if you learned something new, give it a thumbs up and subscribe to my channel, hit that bell icon as well. You can follow me on my other social media if you want. Links for those are going to be in the description of this video. Thank you for watching, and I'm going to see you in my next video. Bye! Hi everyone, welcome to my channel. In this video, I want to explain how you can use pointers in order to return multiple values from a function. So I said in the first video of this playlist that using pointers to return multiple values from a function is a very common use for pointers. So in this video, I want to demonstrate how that works. So here we are going to create an array of numbers, and then first I want to create 2 functions, and one of those 2 is going to return me the smallest number in that array, and then the other one is going to return me the largest number in that array. And then in the second part of this video, I want to show you how you can use pointers in order to get both smallest and largest number using one function only. So you can return both of these numbers, so min number and max number, using only one function, and that is going to be with the help of pointers. So let's start with this example. As I already said, I'm going to create an array of numbers. So those are going to be numbers of type int, and let's call this array numbers like this, and it is going to be an array of 5 numbers, and let's assign them values of, for example, 5, 4, minus 2, 29, and 6, for example. So those are going to be my numbers. Okay, and now let's create a function that is going to return the smallest number of this array. So I'm going to create that function here, and let's give it the return type of int, and I'm going to call it get min, like this. And what I will need to pass to this function is going to be array, so this array here. So I'm going to say int numbers array. So this is going to be the first argument, and then the second one is going to be the size of this array. So I'm going to say int size, and we will use this second parameter here so that we know how many iterations we have to make in order to go through all of the elements of this array. So let's define this function. The first thing that I want to do is I want to create a variable of type int, and that variable is going to be called min. So this is going to be the variable that is going to hold the minimal value, so the smallest number in this array. And initially I want to assign to this variable the first element of this array. So I'm going to say that the smallest element initially is going to be the first one. So I'm going to say numbers of 0. And then we are going to iterate through all of the other elements, and each time that we find an element that is smaller than the current value of our min, we are going to store that value in our min. So let's do that. So I'm going to say for, and since we have already stored the value of our first element in our min, we do not need to iterate through that. So I'm going to say that my int initially has the value of 1. Okay. Oh, int I is equal to 1, like this. And then our for loop is going to iterate while our I is less than the size of this array. So in this particular situation, while our I is less than 5. And in each iteration, we want to increment our I, like this. So as I already said, if we find a number on a specific position, which is in this current situation, the position with the index of I, if we determine that that number is smaller than our min number, like this, we are going to store that number in our min variable. So I'm going to say min is equal to numbers of I, so that at the end of this for loop in our min variable is going to be the smallest number of this array. So at the end of this for loop here, we can return our min, like this. Okay, so now in order to test this function here, I'm going to invoke it. Let's say get, actually I'm going to write it out. I'm going to say cout min is, like this. And then let's invoke it. Let's say get min, like this. And this get min function receives array. So let's pass it numbers array, and then it receives the size of this array, and this array has 1, 2, 3, 4, 5 elements, and you can check that here as well. So we are going to pass 5 here. Okay, and if I run this program, as you can see, it says min is -2, which really is the smallest number in our array. So that is going to be the first function. And then the second function that I want to create is going to be the one that is going to return the largest number in our array. So let's copy this function. I'm going to copy it and then just modify it a little bit. So the name of that other function is going to be get max, like this. And then that function as well will receive numbers array and the size. But here we are going to have a variable which is called max instead of min, and again we will assign it the value of our first element. So then we iterate through all of these elements, so starting with the second element, because first the value of the first one we already have inside this variable, so we do not need to check that. But if we find in these remaining elements, if we find element that is larger, so bigger than our max, let's copy this here, we are going to store the value of that element in our max variable, like this. And then at the end, we will return our max variable. Okay, so now in order to test this function, I will invoke it as we did with this previous one. I will just say max is, and then invoke get max like this. And I'm going to add 2 end lines here so that we have output which is formatted nicely. And if I run my program now, as you can see, it says min is -2 and then max is 29, which is correct. So let's explain one more time the algorithm that we are using here in order to determine the biggest number of our array. So here in this first line, I say that the biggest number is the one with the index 0, so the first one. And then here we iterate through all of the remaining elements, and that is from the one with index 1 until the last one. And if we find that any of those remaining numbers is greater than our max number, then we say that our max number is equal to that number. So at the end of this for loop, we will have in our max variable the largest number of this array here. Okay, and we have accomplished to get our min number and then our max number using these 2 functions. Oh, I'm sorry. So using this get min and then get max function as well. So now what I want to show you is how you can use one function only to get both min and max number. So let's do that. Let's create a function which we will name void get min and max like this. And this function is going to receive, like these 2 previous functions, our numbers array and the size of the array. And then considering that we want to return 2 values from our function, we will have to pass those 2 values by a reference, which means we will have to pass the addresses of the 2 values, and then this function here is going to change the value that is stored on those 2 addresses, and this function here, our main function, is going to have the access to those 2 addresses as well. So once this function here assigns the value of min and max numbers to those 2 addresses, our main function is going to be able to access those values. So as I said, let's pass to this function as well int min like this, and then int max. So we are receiving here pointer to a min number and then pointer to a max number. Okay, so the job of this function will be very similar to the jobs of the 2 functions that we just created. So I will just copy this and then paste it here. And once more, we are iterating through all of the numbers of our numbers array. And then here we say if you find any number which is greater than our max number, and here we have an error which says operand types are incompatible, so int and int pointer, which means that here we have to dereference this pointer using the star symbol. So if you find any number which is greater than our current max, please store that number inside our max like this. And then I'm going to copy this code one more time for our min number. So I will say if you find any number which is smaller than our min number like this, please assign that number to my min number like this. So this is going to be the work that this function will do. And considering that this function is receiving these 2, so min and max, as pointers, this means that this function is directly going to modify the values that are stored on these addresses. And those same addresses are going to be available in our main function, which means that once this function changes the values that are stored on our max and our min address, this main function here will be able to access those changed values. And using pointers, in that way we have achieved to return multiple values from our function. So let's invoke this get min and max in order to test what I just said. So I'm going to comment these 2 lines of code because we do not need them anymore. And because here we have to pass min and max, we will have to create those two variables here as well. So I will say int min, and as we did before, I'm going to assign to this min the value of my first element, like this, okay? And then I will create max variable as well and assign to my max variable value of my first element as well. And now let's invoke this get min and max function. So let's say get min and max, and let's pass it parameters that it needs. So the first one is numbers array, so I will say numbers, and then second parameter is size of that array, so 5, and then it expects to receive two pointers, so min and max, and we will have to pass addresses of our min and then address of our max as well, like this. And this here is called passing a parameter using a reference. So that means pass an address of a variable to your function rather than passing variable itself, because then if you don't pass an address, your function is going to create a copy, and whatever changes your function makes with that copy, you will not be able to see those changes in your main function. So in this way, we are passing addresses, which means that this function here is operating on the original addresses, which this function here is accessing as well. So when this function here changes the values that are stored on those addresses, this function here will know. So that means that now if I try to write out, I will need to add semicolon here at the end. Okay, so that means now if we try to write out our min like this, min is, and then min, and then if we try to write out our max as well, max, we will get values of -2 and 29. At least we expect to get those two values if this function is working correctly. So if I run my program, as you can see, we really have values of -2. Let me just collapse this. So we really have values of -2 and 29 as the smallest and the largest number in our array. And we have achieved that using this pass by a reference. So by passing addresses of our variables to our function, which our function then changes the values that are stored on those addresses, and since this main function as well has the access to those same addresses, that means that our main function can see the changes that have been made on those addresses. So I hope that now you have an idea how to return multiple values from a function using pointers. So if you enjoyed this video, if you learned something new, give it a thumbs up and also subscribe to my channel. And I will be publishing more videos related to pointers in the future, so if you don't want to miss out on those, press the bell icon as well. Thank you for watching, and I'm going to see you in my next video. Bye! Hi everyone, welcome to my channel. My name is Saldina and I make IT and programming related videos, so if that is something that is of interest to you, consider subscribing to my channel and give this video a thumbs up as well. And in this video I want to talk about dynamic arrays. So you should already be familiar with the idea of arrays and the concept of fixed arrays from my previous videos, but for those of you that really want to understand the need for dynamic arrays, I will go through some of the advantages and disadvantages of fixed arrays so that you can really understand where the need for dynamic arrays arised. So we said that an array is type of collection which stores elements in continuous memory. Now that means that it stores elements one after the other. So if I do this, for example, if I say let's create an integer array of 5 elements and let's call that array my array, like this, your computer in the background will do the following. It will give to this array here 5 containers of type int, and those containers will be one after the other in memory. So that means because the array stores data in a continuous memory, so one after the other, accessing that data will be very, very fast. So because the name of the array is the address of the first element of that array, when you specify the name of the array and then you give it the index of the element that you want to access, it is going to be very fast to move from that first element until that position that you specified, so until the element that has that index. Whereas if you used some other collection type like linked list, for example, which stores data in non-continuous memory, which means in a random places in memory, and then each element contains a pointer to the previous one and to the next one, accessing elements in those type of collections would be much slower. So if you wanted to access fifth element of linked list, you would have to traverse the first four elements and then get to the fifth one, because they are stored in non-continuous memory, meaning they are randomly in your memory. So, as I already said, accessing elements of an array is a very, very fast operation. But because your array stores data in continuous memory, this has certain disadvantages as well. So, what happens if you want to insert or delete an element in the middle of the array, for example? So how can you insert or delete an element in the middle of the array without breaking that continuousness, if I can say it like that? So you get the point. That means that the operation of inserting and deleting elements in an array is going to be much slower than inserting elements in a linked list, for example. And if you want me to do a video which is related to differences between linked lists and arrays, for example, write it in the comments down below and I will make it in the future when I find time. So again, if you are not familiar with the basics of arrays, I recommend you to watch my first video, which is related to arrays and pointers, which I will link here, and then you come back to this one. So those were some advantages and disadvantages of arrays, and it will be up to you to decide which collection you want to use. However, here I want to give you the biggest disadvantage or the biggest obstacle that we encountered so far when working with arrays, and that is the following. So the size of the array had to be constant, which means that the size of the array had to be known before we even started our program. So we always kind of wanted to do this. So we wanted to say int size, and then we wanted to ask our user to enter the size. So please enter the size for the array. And then after our user enters the size for the array, we wanted to create the array that is of that size that our user specified. However, we get the error. As you can see here, it says expression must have a constant value, which confirms what I just said, which is that the size of the array had to be known at compile time. So the size of the array could not be changed once we declare it, and we had to declare it before we even started our program. So this problem was without solution so far, but surprise, surprise, if you know how to work with dynamic arrays and dynamic memory, you can very easily create an array in runtime. So in C++, there are two keywords or two commands which allow you to allocate and deallocate dynamic memory, which means to get yourself dynamic memory when you need it and then free that memory once you don't, so that it can be reused. That is what allocate and deallocate means, and those two commands are new and delete. So new allocates memory, as you may guess, and then delete deallocates that memory or frees it once you don't need it. So let's see how we can use this information that I just gave you on our example. So instead of doing this here, I will comment it because we do not need it. Instead of doing this, what I will do is I will create a pointer like this, and let's call that pointer my array. And what I want to assign to this pointer will be the following. I will say, please make this pointer point to new integer array, and the size of that array will be this size that our user entered, like this. Okay, and as you can see, our compiler is fine with this expression here. We do not have an error. So this new keyword has allocated an array of this size that our user has specified. And that array, the address of the first element of that array, is stored in this myArray pointer. So if I build this code, as you can see, we do not have compile time errors. So what I want to show you now is how we can enter elements for this array and then how we can write them out. And this is array, again, this is array which is created at runtime. So our user will specify the size of this array, which is something that we were not able to do before we learned how to use dynamic arrays. So in order to enter elements for this array here, as we already know, we will be using for loop. So I will say for, please iterate from the element which has index 0 until you come to the element that has the index of this size. Okay, and then in each iteration, increase our counter by 1. And what I want to do is I want to write out a message for my user. So I will say array, and then let's add index of the current element, index that our user is entering. So I, like this. Okay, and then what I want to do is I just want to enter an element on that position that we are currently iterating. So I will say my array of I, like this. So using this code here, we should be able to enter elements in this array here. And then in order to write these elements out, what I will do is I will use another for loop. So I will just copy this one and then paste it here. And in this particular situation, I just want to write out. So I will use cout command and then these other redirection signs. So I just want to write out all the elements of the array, and I will add a few empty spaces after each element so that we have nicely formatted output. So this loop here should write out the elements of our array. And if I start this program now, as you can see, it asks us to enter the size of the array. So let's say 5, for example. And now we are entering element with index 0. So let's say 2, 5, 7, 9, and let's say 11. Okay, and as you can see here, we have the elements of our array written out. And we wouldn't be able to do this if we didn't know how to work with dynamic arrays. So let's stop this program. And there is one more thing that I want to mention, and that is following. These square brackets here are only one way to dereference your array. Another way to dereference the array or to access the element on a specific position is the following. So the other way to access the element on a specific position would be using this asterisk symbol, and then here you say my array plus I. Now, because the name of the array is the address of the first element, here you have the address of the first element, and then when you add a certain number to that, it will move that many spaces in memory and then access the element on that position. And when you dereference that, you will get the value of that element instead of its address. So here is one way to dereference your array, and then here is another way to dereference your array, and you can use whichever one you prefer. And if I run this program again, just to demonstrate that it works the same, let's say 3 and then 1, 5, 10. Okay, we get 1, 5, 10 as the elements of our array. One very important thing that I mentioned at the beginning is that we have two commands for working with dynamic memory, and one of those two commands is new. So we said that new is a command which will allocate memory for us when we need it, and then another one is going to be delete, and delete is a command which will deallocate that memory when we do not need it so that it can be reused. Now, using dynamic memory comes with a responsibility, and that responsibility is the following. Each time that you allocate memory when you need it, you will have to deallocate that memory once you don't, so that that memory can be reused. So that means that each time that you write new command, you will have to write delete command once you don't need that memory anymore. So I will demonstrate how can you deallocate the memory that we have allocated for this my array. So let's say that here in this line of code, we do not need our array anymore. So how can I deallocate the memory that I allocated for this array? Well, using delete keyword. And I will say, please delete the memory that I allocated for my array, which is called my array, like this. And you have to specify these square brackets because that is the way that you allocated memory. So here you said, I want new array, and then here you have to say, please delete that array. And a good practice is to do the following as well. So you can say, my array is equal to null, like this. And let me collapse this. So this here is going to assign the value of null to your array. So your array will not point to anything, to any address at this line of code. So why do we do this? Because in the previous line of code, we have deallocated this array here. And now in this line of code here, your array will point to a location in memory which does not belong to you, so it does not belong to your program. And because of that, because we do not want to cause some accidental crashes or problems in our program by having this array pointing to memory locations which are not ours anymore, it is a good practice to say that our array is now equal to null, which means that it is not pointing to anything. So as I already said, and I repeat again, when you use dynamic memory, each time that you write new, you will have to write delete that corresponds to that new. So here I have allocated an array, and here I am deallocating that array. So I hope that this video was helpful and that this video helped you understand what are dynamic arrays and how they work. And now that I have explained this, it opened the whole world of new possibilities and new things that you can do with dynamic arrays. And I will leave to you to play and discover those new things until my next video, of course. So thank you for watching this video. Give it a thumbs up if you liked it. Subscribe to my channel, click the bell icon as well. And I'm going to see you in my next video. Bye! Hi everyone, welcome to my channel. My name is Saldina and I make IT and programming related videos, so if you're interested in those, please subscribe to my channel and give this video a thumbs up. And in this video, I want to talk about a topic that confuses many students, and that is the topic of multidimensional dynamic arrays. And the topics like this one are the reason why many people step away from learning C++, and they believe that learning C++ is hard. But what I think is that many of those people never actually had the opportunity to have this explained in a very simple way. So that is what I will try to do in this video. So with the help of Excel, I will try to draw what are multidimensional dynamic arrays and how they work. And I hope that at the end of this video you will have it pretty clear and you will be able to create and work with your own multidimensional dynamic arrays. So what a multidimensional array is, in simple words, it is an array of arrays. And in this video you will learn how to create two-dimensional dynamic arrays. And in order to be able to understand this topic, you should be familiar with the topic of dynamic arrays, which is a video that I already did on my channel, and I will link it here, so make sure to watch that video before watching this one. So I will very quickly remind us all of how dynamic arrays work, and then we will see how we can use that knowledge to understand multidimensional dynamic arrays. So let's create a visual representation of a dynamic array in our Excel sheet. So let's say that it will be an array of 4 elements, like this. This is our array, and the indexes of these elements start with 0 and then 1, 2, 3. So these are the indexes, and then the address of this first element will be, for example, 0000AA, like this. And this address here, it is the address of the first element, but it is the address of the array itself as well, and you should be familiar with that. So this here is our dynamic memory, and then on our stack, which will be here, let's create our stack. So this here will be our static memory. Here we will have to create a pointer variable which will hold the address to this element here, or actually the address to the array itself. So I will create a variable, let's call it ptr1. So this is going to be our pointer 1, and as we already said, that pointer will hold the address of the first element of this array. Let's copy that address like this, and then we will store that address in our ptr1. Now, if we wanted to create more arrays, by the knowledge that we have so far, we would have to copy this, and then let's paste it here, and let's create one more array like this. So now we have 3 dynamic arrays, and the first element of the first array has the address of 0000AA, and then this one here, let's say that it has the address of BB, for example, and then this one here has the address of 0000CC. And to be able to access these arrays, we would have to create on our stack 2 more pointers. So let's do that. Okay, so our pointer 2 will hold the address of the second array, which is 0000BB, and then our pointer 3 would hold the address of our third array, which is 0000CC, like this. Now, with this, we have created 3 dynamic arrays, and in order to create those 3 dynamic arrays, we had to create 3 pointers. So those are these 3 here, and this is something that you should already be familiar with. So you should already know from my previous video how to create a dynamic array. Now, one thing that I see here, and that is a problem, is that if we wanted to create 4 or 5 or 100 of these dynamic arrays, we would have to create that number of pointers on our stack, which means that this part here is not dynamic. Only this part here is dynamic, because here our user determines how many elements this dynamic array will have, but for each of these dynamic arrays, we have to manually create a pointer on our stack which will hold the address of that array. Okay, now what happens if I want to move this part here to our dynamic memory as well? So let's do that. Let me cut it from here, and then I will paste it here, for example. So now I have moved this part to dynamic memory as well, and as you can see here, this kind of looks like an array as well. So that means that this first element, if we look at this as an array, the first element will have index of 0, and then second will have index of 1, and then third will have, oh, this won't move. Third will have index of 2. Okay, so this is an array that has 3 elements, and the first element, for example, has the address of 00EEEE, like this. So now this part here is dynamic, and then this part here is dynamic. And in order to be able to access this array here, what we have to do is on our stack, which is this part here, we will have to create a pointer which will hold the address of this first element. So let's do that. Let me just, okay. Now, as I already said, on our stack, we will have to create a pointer which will hold the address of this first element. So let's call that pointer table, for example, and this table will hold the address of this element here, which is 00EEEE. And this table, because it holds the address, it should be a pointer. But one thing to keep in mind is that this variable here is not a simple variable, but this here is a pointer as well, which means that this table will not be a simple pointer, but it will be a pointer to a pointer. And you indicate that using 2 asterisk symbols, because one is just a pointer, and then 2 mean a pointer to a pointer. Why? Because this table holds the address of the element, which is this one here, and that element is pointer as well. Okay, now if we look at this here, as you can see, we have one array that represents the number of rows that our table will have. Okay, so 1, 2, 3, and then for each one of the elements of this array here, we create a separate dynamic array like this. So this here will be our table that has the number of rows that our user defines, and then however many columns our user defines as well. And in this particular situation, it is a table that has 3 rows. So these are 3 rows, and then 4 columns. So let's now translate this to our C++ code. And because we said that now our user defines how many rows this table will have and then how many columns as well, that is the first thing that I will do. So I will create 2 variables. Let's call them int rows and columns. And then I will ask my user to enter how many rows and how many columns he wants this table to have. So let's do that. Cin rows, and then columns, like this. Okay, now after our user has entered how many rows and columns he wants, what I want to do now is this part here. So this part here, this is our first step, and then this here is going to be our second step, and this part here will be the third step. So this part here will be the following when translated to C++ code. So here, as I already said, I create a pointer to a pointer, which I will call table. So I will say, please create an integer pointer to a pointer, because here we will store integer values. You can create a character or a double or float, whichever one you want. I want to create integer pointer to a pointer and call that table like this. Okay, so we are done with this first part here. And then what this table pointer to a pointer will point to is going to be this array here. So I will say, please create a new integer array that has this many elements. So the number that our user has entered for this rows variable, because this rows variable holds how many elements this array here will have. But as you can see here, we have an error, and that error is happening because this here, which is this array here, is not just a simple integer array, but it is an array of pointers. So here you will have to indicate that. So you will have to say, please create an integer array of pointers. And as you can see, now our error has disappeared. And with this line of code here, we have created this array here. Now, our third step is going to be that for each element of this array here, we would have to create a separate dynamic array. So this first element will hold the address of this dynamic array, and then this second element holds the address of this array, and then this third, the address of this array here. So what I will have to do is I will have to iterate through all the elements of this array, and for each one I will have to create a separate dynamic array. So let's do that. So I will say for int I is equal to 0, and then I is less than the number of rows that our user entered, and in each iteration increment I. So in this particular situation, our number of rows is equal to 3, but you can have as many as you want. So what I want to do in each of these iterations is I want to create for each one of these elements a separate dynamic array. So I will say table of I is equal to new integer array that has this many elements. And that is the number that we stored in our columns variable, like this. And with this code here, we have successfully created these dynamic arrays. Now, how do you access elements on a specific position of this table here? For example, this one or this one or this one. So in order to do that, let's say, for example, table of row 1 and then column 2 will have the value of 88. Now, what this code here, what this line here will do is the following. So this part here, it says, please give me the table variable, which is this one here, and it is a pointer to a pointer which holds this address here, so 00EEEE, and that address is the address of this element here, so the address of this array. And here we say, please give me the element of that array that has index 1, which is this element here. So it is the element that stores the address of 0000BB, which is the address of this array here. And this second part says, please give me the element of that array that has the index of 2, which is this element here. So here we will store the value of 88. So that is what this line of code here will do. It will store number 88 to this position here. So this line of code here will store this number at the element that has row index 1 and column index 2 of this table. So this here is the row with index 0, this here is the row with index 1 and then 2. So we are storing at this row, and then column index 2 is this one here. So here we store number 88. One thing that we said as well in my previous video is that each time that you allocate dynamic memory, you have the responsibility to deallocate that memory when you don't need it, which means each time that you use new keyword, you will have to use delete keyword when you don't need that memory anymore. So now is the question, how do we deallocate all of this memory that we have taken? So in order to do that, what I want to do is I want to show you something. If for some reason we lose this address here, so the value that is stored in this table pointer to a pointer, we will never be able to access all of these elements that we have created in our dynamic memory. So that means that we will not be deallocating this first. And then if we for some reason lost this, the value of our 0000AA, for example, that means that we would never be able to access this array here. So we would never be able to deallocate this memory. So that means that this is not going to be deallocated first as well. Now, allocation of this memory here went as follows. This was the first step. So this was the first thing that we allocated, and it is this code here. And then we allocated this. So that corresponds to this part here. And then the last thing to allocate was these arrays here, and that corresponds to this part of the code. And the allocation of this memory will go the other way around, which means that first we will deallocate this, and then we will deallocate this, and then this will be the last thing that we will have to worry about. Now, in order to deallocate this, the process will be almost the same as the one when we allocated it. So I will copy this for loop and then paste it here. But what I want to do in this particular situation, so when deallocating, is instead of creating a new dynamic array for each table of I, is I want to delete that array. So for each element of this array here, I want to delete the corresponding dynamic array. So I want to delete these 3 arrays. And in order to do that, I will say, please delete the array that my table of I is pointing to. Now, what this code here will do is for this element here, it will deallocate this array here. So let's delete that. And then for this element here, it will deallocate this array. And then for this one, it will deallocate this array here. So now we have successfully freed this memory that we have taken here. Now, after we have done this, after we have successfully deallocated our first step, which was here, this part here will be our second thing to deallocate. So here I will say, please delete the array that my table variable is pointing to. So this line of code here will deallocate this part here. So I will say, please delete that. We do not need it anymore. Okay. And then our third step, which is the last one, will be to null this value here. Why? Because we have just freed the memory that was here. So we have deallocated that. Now someone else might be using this memory here, and we really shouldn't keep the address of someone else's memory. So we should make this a null value like this. And in order to do this in our code, I will just say, now my table will hold the value of null like this. And this will prevent some potential crashes and problems in your application. So I hope that this video helped you understand multidimensional dynamic arrays a bit better. And if it did, please give it a thumbs up and subscribe to my channel, because that helps me to reach more people and hopefully make programming a little bit easier for them as well. Thank you very much for watching, and I'm going to see you in my next video. Bye! Hi everyone, welcome to my channel. My name is Saldina. I'm a software engineer and I make IT and programming related videos here on YouTube. And in this video, I will be doing something that I haven't done before, and that is reviewing your code, and we will see some errors that you guys have sent me. So I get a lot of messages, a lot of questions on my Instagram, on Twitter, and then here on YouTube as well in the comments, where you ask me for an opinion or for advice on certain errors that happen to you in programming. And I try to answer as many of those as possible, but it's just not possible to answer to all of you, and I'm very, very sorry. But I thought that it would be a good idea to make a video related to that so that all of you can see it. So here I am, I'm making that video right now. So in this video, I will be reviewing some code, and we will see some errors that can happen and that do happen very often. And I'm going to do that both manually, and then I want to show you a very cool tool which is called PVS Studio. I'm going to leave details in the description down below so that you can check it out for yourself. But what PVS Studio is, it is static code analyzer. So it is basically a tool that reviews your code and helps you detect bugs and errors and security weaknesses in your code. So in the case that you need another pair of eyes to look at your code and give you a few tips and recommendations, it is a great tool to use. And you can get it as a team license for teams up to 9 people, or you can get an enterprise license for bigger companies, bigger departments, or you can even request a free license if you are a student, if you are working on some private projects or on some open source projects. And then one very cool thing is that it is not only used to analyze C++ code, but you can use it for C and then C# and Java as well. And I am wondering, guys, which team are you in? Are you team C++ or are you team C# or Java or C? I'm very curious to read your answers, so please write me in the comments down below. And if you ask me, I'm definitely team C++ and then team C#. Those are just two of my favorite languages ever, but I am very curious to read what you will answer to this question. So I'm going to leave all the details about PVS Studio in the description of this video so that you can check it out for yourself. And let's jump into the coding part right now, because I am very, very excited to do this. Here I have created a new project and I have this program that does basically nothing. So what I want to do is I want to check if everything is okay with this code so far. So if we have made any errors so far. So I'm going to click on extensions and then PVS Studio, and here you have multiple options. You can check your current file, you can check open files, or you can check your project, selected items, solution. I'm going to select this first option, so I'm going to check this current file, and you get this window here. And as you can see, we have one error, and that error is that my license will expire in 5 days. Okay, so that is not error which is related to our code, so we are just going to ignore it. So we don't have code errors so far. And let me show you how you can install this tool very quickly. So you click on extensions and then manage extensions. Okay, and then here you can search for PVS Studio like this. Okay, great. It is this one here. So PVS Studio is a tool for detecting bugs and security weaknesses and so on. Okay, so you will click download here and your download should begin. I'm not going to do that right now because I already have it, but once it is downloaded, the installation is pretty simple. So it's basically next, 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 finish installation. So that should be simple. Okay, now let's close this window here. And as you could see, we don't have any errors with this code so far. So let's write some code and let's create some errors now. So let's create an array of type int, and I will call it saved money, and that will be an array of 5 elements, and I want to initialize those elements here. So the purpose of this array is following. Let's say that I want to save some money each month, and I want to store that data in this array here. So I'm going to save money for 5 months, and I will store how much money I have saved each month inside this array here. So for example, the first month I have saved $100 or euros or whatever, and then second month I have saved 200, and then 300 and 400 and 500 fifth month. Okay, so this is our array. Now, what I want to do with this data here is I want to sum it. After 5 months, I want to know how much money I have saved in total. So I'm going to create a variable of type int, and I will call it total, like this, and I will initially give it a value of 0, and then I will iterate through this array here. So I will say for int I is equal to 0, and then I is less than or equal to 5, and then I plus plus. And what I will do inside this for loop is I will say that my total will hold whatever my total was previously holding, plus current value of how much money I have saved in that month. So saved money of I. Okay, now after I have done this, I will just write out how much money I have in total. So I will say total, and then this value that is stored inside this variable here. Okay, now if I run this program, let's see what will happen. Well, it says that in total I have minus 8 billion something, very, very big number. So I have tried to save each month, and then at the end I have minus $8 billion, so that does not make any sense. So here we have a logical error. Okay, so let's see what is this error that is happening. So let's click on extensions and PVS Studio, check current file to see what kind of error PVS Studio sees. And it says array overrun is possible. The value of I index could reach 5. And if I double click on that, it will take me here. And this part of code here is underlined, and this is actually our compiler. Our compiler is underlying this, and it says that, okay, it says index 5 is out of valid index range of 0 to 4. So this here, this situation here says that this I is out of range of valid indexes that this array here can have. And if you are familiar with arrays, you know that indexing of an array starts with 0. So the first element has index of 0, and then 1, 2, 3, and 4. So valid indexes for this array here are from 0 to 4, and here we have accidentally written that this I is less than or equal to 5, and that is making a problem. So if I delete this part here, so if I say that my I is just less than 5, this error should disappear. So if I click on PVS Studio and then check current file, the error should disappear. Okay, it has disappeared now. So if I run my program, this program is behaving as expected. So this is one thing that very often happens. You can accidentally write less than or equal to, and then you can get a very, very big logical error. Another thing that can happen is if you're typing very quickly and if you lose concentration for a moment, and here instead of incrementing, you decrement this counter. So you say I minus minus, you should get an error as well. So if I try to build this program, let's see what our compiler will tell us. So here in this error list, it says ill-defined for loop counts down from minimum. So that's kind of helpful information. And then let's read this other warning. It says reading invalid data from saved memory. The readable size is 20 bytes, but minus 4 bytes may be read. So this is not really helpful for someone who is just starting. And then this third message, it says index minus 2 billion something is out of valid index range 0 to 4. Again, this is not really helpful for someone who is just starting. So let's see what our PVS Studio has to say. So I'm going to click extensions, PVS Studio, check current file. Okay, and this first error here says the condition I less than 5 of for loop is always true. So this is actually a helpful message, and if I click on this, I will be taken here, and it says that this condition here, I is less than 5, is always true. But why is it always true? Because we have started counting at 0, and then we try to decrement that value in each iteration, and doing that we can never reach this condition here. This condition here will never become false. So that means that here we have created an infinite loop. And here our PVS Studio says, consider inspecting this for operator. So consider inspecting this for loop here, because it will not be executed at all, or it can be executed incorrectly. And in this particular situation, it is going to be executed incorrectly. So it is going to be an infinite loop, which we don't want in this particular situation. So I'm going to correct this error here. So I'm going to return it to I++. But that is sort of a help that you can get from PVS Studio. And this here is a pretty simple program because it has just a few lines of code where all the bugs can potentially happen. But imagine working on a very, very big project and then something like this happens. So imagine something like this happening on a program that a bank uses. So you are trying to save money for a couple of months, and then the program says that you are in debt, that your balance is minus 2,000 or 20,000 or something like this. So this can create very, very big issues. And in this particular situation, if you have a bug like this, you will want to have all the help that you can get. And sometimes that can be just the help that you get from your compiler, or if you have a very, very big problem, you will definitely benefit from tools like PVS Studio, which will give you some additional information on that situation that is happening and on that problem that you are having. And then there are other situations where you can have very, very big problems, but your compiler will not be helpful at all, because your compiler will not be able to see those potential bugs that you are creating inside your code. So in order to demonstrate that, let's delete all of this code here, because I will not need it anymore. And what I do need is to create a function here. So let's create a function of return type void, and I'm going to call it my function, like this. Okay, and what I want to do inside this function is I want to create an integer pointer, PTR. So if you're not familiar with the topic of pointers, make sure to watch the playlist that I will link here. It is the playlist where I explain pointers in C++, because it is one of the most important topics in C++, and it is the example that I will be using here. So I have created an integer pointer, and I'm going to say, now you will point to a new array of integers, and that array will have 5 elements, like this. Now, what do I want to do with this array? Well, let's do something very simple. Let's say ptr of 2 will hold the value, okay, it will hold the value of 10, like this. And then let's just write out something. Let's say, hi, I am equal to, and then ptr of 2. Okay, so this here is pretty simple example that does basically nothing important, nothing useful, but I will use it to demonstrate a very, very big issue that can happen in this situation. So I'm going to invoke this function here. So I'm going to say my function, like this, and I have successfully invoked this function. So if I run this program, it says, hi, I am 10. So nothing unexpected happened. Or did it? Okay, if I inspect my errors list, it says that I don't have any errors. So if you ask a compiler, it will tell you that everything is perfectly fine. So let's now ask PVS Studio. Here it has already detected 2 potential issues, but you can click PVS Studio and then check current file just to be sure. Okay, and it says visibility scope of the PTR pointer was exited without releasing the memory. A memory leak is possible. So what we have done here in this program is we have created memory leak. Where? Here. So here we have said, please give me, in my dynamic memory, give me an array of 5 integers. And this is going to be done in dynamic memory. So once this function is finished, once this function ends, we are going to lose this PTR. So we are going to lose the address of the first element of this array here. So here, if I try to do something like PTR, I cannot access this variable here anymore. This variable has its scope, and that scope is inside this function here. And once this function exits, we are going to lose the address of this array here, which means that we will not be able to deallocate this memory here. Now, let's delete this. Okay, here, as you can see, this memory leak is not a big memory leak. Here we are leaking 5 integers. So we are leaking an array of 5 integers, and that is not very big problem. But usually what happens in real life is that you are not creating an array of 5 integers. Usually you are creating things that require much more memory than just an integer array of 5 elements. So here, as I said, we are leaking 5 integers, but imagine a situation where you're creating an array of 5,000 or 50,000, and not integers, but objects of type user, like this. And this user has some pretty heavy data in it. For example, it has some images and things like that. So here you are creating 50,000 users. And to make things worse, imagine not invoking this function only once, but imagine invoking this function in a for loop, for example. So invoking it 100 times or 1,000 times or 100,000 times. That is going to be a huge memory leak. So what this line of code here does is it asks your operating system for dynamic memory. So it says, please, can you give me new memory? So can you give me dynamic memory that I need to store this data here? And your operating system gives that memory to your program. So it allocates that memory for your program. And then once this function here finishes, you will lose all the variables that you have created inside that function. And that is this PTR variable here. So that means that the address of this array here, which was stored inside this PTR variable, is lost now. And now you will not be able to deallocate this memory here, which means that you will not be able to say, okay, now I am done with this memory, which is a lot of memory, and now I'm going to return that back to my operating system, because I don't have unlimited amounts of memory, and my operating system maybe would like to give that memory to some other program. So once this function here ends and you don't deallocate this memory here, you are leaking that memory. And that is exactly the error that you have here. It says a memory leak is possible, whereas your compiler here said expected a type specifier, which is error that we have here because it does not know what is this user. So I'm going to return this back to int. Okay, now that error has disappeared, but your compiler does not know that you are leaking memory here, whereas your PVS Studio analyzer here says that a memory leak is happening. So how do you fix this error here? Well, for each new, you need to have delete. Again, you need to watch my C++ pointers playlist in order to understand pointers if you don't understand this already. So as I said, for each new you need to have delete. So I'm going to say delete, and let's delete this PTR. Let's see what is going to happen now. So if I click extensions and then PVS Studio check current file, it says the memory was allocated using new array type operator, but it was released using delete operator. And then it gives you a recommendation here. It says use delete array pointer instead. So here we are trying to allocate memory for an array, but we are not deleting that entire array. So here we are leaking memory again. So here I'm going to use these square brackets in order to indicate that I want to delete this entire array that I have allocated in this line of code here. So now we shouldn't be leaking memory anymore. So let's check that out. I'm going to say PVS Studio check current file, and let's see. We have that error that we previously had, which is your license will expire in 5 days, but we do not have memory leaks anymore, which is great. So errors like this, memory leaks, are very common when you work with pointers in C++, and these memory leaks can create huge problems if you have them in your code. And as you could already see, in most cases you cannot really count on your compiler to tell you that you are leaking memory, because in most cases it will not even be able to see that. So tools like PVS Studio can be very helpful in those situations. You could see all those little tips and recommendations that we had from PVS Studio that helped us to fix issues that we had related to leaking memory. So those were some topics that I wanted to address in this video, because many people, when working with pointers, will come across problems that they will not be able to fix, or they will not even be aware that they have those problems, that they have memory leaks, until it gets to the point where it is unmanageable and they have very big problem, they have huge problem. So if you have any more questions that you would like me to make a video on, please leave those in the comments down below. And if you like this type of video, please give this video a thumbs up so that I can know, and I will make more videos like this in the future if you want me to. So thank you very much for watching this video, and I am going to see you in my next video. Bye! Hi everyone, well okay, so hi everyone, welcome to my channel, welcome to another Hi everyone. Hi everyone. Welcome to my channel. So this here is the initialization step of our initialization
Initialization.
So it is the